नमस्ते बेटियों, खुश रहिए. I JV Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in JVWU Women's University and the Faculty of Education and Methodology. So today's session, in which I will discuss the topics that's your Shannon's capacity. And just previous this session, I have discussed with the transmission impairment, transmission media, isn't it? OSI model, OSI layer, and layer architecture, various many more sessions I have discussed in the just previous. So please read that all sessions, and through which you can understand the further topics which will be discussed in the today's session and the next session. Clear? So just prepare that all sessions also. Now, we are just going to talk about the Shannon's capacity. What is the Shannon's capacity? What is the use of this ones, isn't it? And what is the importance of Shannon's capacity in computer networking? We will discuss these all the things in this session. So, to make it an easy way to understanding to all of you, just I am going to share the some files which is created by me to help you to better understanding in this thing. Okay, so hold 1 minute. Yes, this one is the here transmission. Yes, this is the basically your Shannon's capacity, which I will discuss with you today. Okay, so here just which I have shared the file. This is this one, Shannon's capacity. So, what is the Shannon's capacity? There are two types of the Shannon capacity is also known as the noisy in the channel, noisy channel, isn't it? Just before I have discussed the transmission media. Transmission media is what? This is giving you a communication channels through which you can transmit the data from one source to another source. That is basically the carrying of the data from one place to the another place. So we have required there is a media through which we can perform these activities and this task. So the channels which causes the distortions or the creating some unwanted um, signals in during the transmissions is known as the noisy channel. Clear? So noisy channel is the Shannon's capacity. So in reality, we cannot have a noiseless channel. The channel is always noisy. Shannon's capacity is used to determine the theoretical highest data rate for a noisy channel. Okay. Shannon capacity is basically used to determine the theoretical highest data rate for the noisy channel. So the Shannon's capacity equals to your bandwidth into log to 1 plus SNR. Okay, SNR. Now, in the AF equations, bandwidth is a bandwidth of the channel, communication channel, and SNR is the signal to noise ratio. Signal to the noise ratio, and capacity is the capacity of channels, and that is in the form of bit per second, and bandwidth is fixed quantity, so it cannot be changed, and hence the channel capacity is directly proportional to the power of the signals, as SNR equals to power of signal by power of noise. Clear? This is well known. This is understood by you. Okay, the signal to noise ratio, the signal to noise ratio is usually expressed in decibel, given by the formula here 10 into log 10 s by n. So for example, a signal to noise ratio of 1000 is commonly expressed as like here what 10 into log 10,000 equals to 30 decibel. Clear? So is example, if we take an example, suppose input 1, a telephone line normally has the bandwidth of 3000 hertz. It means 300 to 33 hertz assigned for the data communications. The SNR is usually the SNR is usually 3162. What will be the capacity for this channel? Isn't it? What will be the capacity for this channel? So for if we are generating the output, so what will be the capacity equals to 3000 into what? Log to 1 plus SNR, your bandwidth into log to 1 plus SNR, that is the same things here, equals to 3000 into, this is the 1 plus SNR is what here, uh, is usually 3162, isn't it? 3162, and here you can calculate it that with the log 2, then it is calculated here 11.62, and this is the itna bit pixels, clear? Itna bit per pixels. Now if you take the another example like the input, the SNR is often given in the decibels. Assume that the SNR decibel is 36 and the channel bandwidth is 2 megahertz. You can see here that 2 megahertz. Calculate the theoretical channel capacity, that is the Shannon's capacity. Now we are calculating the Shannon's capacity is then SNR dV, you have given the SNR dV. Okay, so SNR dV equals to 10 into log 10 SNR, and SNR equals to 10 SNR dV 10, and SNR equals to 10 to the power 3.6, isn't it? 3.6 equals to 3981 SNR. Okay, now your SNR equals to this one's calculated, then you can calculate the channel's capacity. C equals to whatever you have, bandwidth is 2 megahertz, 2 into 10 to the power 6 for converting to the hertz, and to the log 2 3981, and plus 1 is going to be 3982. So when we are calculating this, then it is 24 megahertz, clear? So the Shannon's capacity is this one. So I hope you have well understood about the Shannon's capacity. This is the very smallest topic in your this course. So only you have the some formula through which you have to calculate the Shannon's capacity of the channels, isn't it? So I'm again recall this. Once time again. So Shannon capacity is what? A noisy channel is known as the Shannon's capacity. It is impossible in now today's era that no one channel is noise free. So every channel has must little bit amount of the noises is occurred in that channel. So whenever we want to calculate the capacity of this ones, then we will use the capacity equals to bandwidth into log 2 in 1 plus SNR. In the above equation, bandwidth is the bandwidth of this channel and SNR is the signal to noise ratio, and the capacity is the capacity of the channel in bits per second. Bandwidth is a fixed quantity, so it cannot be changed, and hence the channel capacity is directly proportional to the power of the signal as SNR, power of signal divided by power of noise. Isn't it? SNR is that thing, power of signal is the ratio to the power of noise, and here is the SN and signal to noise ratio, and here is the formula to calculate it, that in the decibels. And so for example, signal to noise ratio of 1000 is commonly expressed like this ones. Okay, so this is the basic Shannon's capacity, and their formula which is used to calculate the Shannon's capacity or the capacity of the noisy channel. So I hope you well understood this sessions. In case if you have any problem in this session, then please let me know your query via drop your query into the comment section box, through which I will discuss your query into the next session with you. Okay, and the questions will be arises through this session is only were define the Shannon's capacity, and in either I will give one numericals to solve the to calculate the Shannon's capacity. Okay, of the communication channel. Okay, thank you.